RDWorks Programı. RDWorks yazılımının kurulumu. Kurulum dosyanızın kaydedildiği dizini açın. RDWorks V8 Setup dosyasına çift tıklayın, iletişim kutusu görünür. Kurulum programı, gerçek programı bilgisayara yüklemek için kullanılacak, birkaç geçici dosyayı çıkaracak ve kopyalayacaktır. Yükle düğmesine tıklayın. Dosyalar ayıklandıktan sonra, ana kurulum programı arayüzü gösterilecektir. Bu pencerenin arka planda kalması bekleniyor. Endişelenmeyin ve pencereyi de kapatmayın. Kurulum yazılımı, USB sürücülerini otomatik olarak kurmak için kullanılabilir. USB sürücüsünü kur düğmesine tıklayarak USB sürücülerini kurun. Kurulum programı, bilgisayardan gelen USB kablosunu lazer makinesine bağlamanızı ve lazer makinesini açmanızı isteyecektir. Tamam düğmesine tıklayın. USB sürücüleri kurulduktan sonra kurulum programı, USB sürücüleri kurulumu tamamlandı mesajı verir. Tamam düğmesine tıklayın. Kurulum programı, RDWorks 8 yazılımını yüklemek için hazırdır. Müşteri uygulama ihtiyaçlarına göre yazılım varyasyonlarının yüklenebileceğine dikkat edin. Lazer makinemize ve ihtiyaçlarımıza uygun seçenekleri seçtiğimizden emin olalım. CorelDRAW, AutoCAD veya Adobe Illustrator içinde çalışmak için tam bağımsız yazılımı veya eklentileri yükleyebilir. Varsayılan seçim, LazerWorks, bağımsız yazılımını yüklemektir. Bu seçimi LazerWorks olarak bırakın. Yazılım, başlangıç konumunu atamak için lazer makinesiyle işbirliği içinde çalışır. Yazılımın lazer makinesinin konfigürasyonuna uygun olması gerekiyor. Lazer makinesinin orijini sağ üstte ise, ekran orijininin eşleşmesi gerekir. Rabbit Laser USA'nın tüm lazer makineleri sağ üst başlangıç konumunu kullanır. Toprak seçeneğini seçmek için, Origin yanındaki açılır kutuyu tıklayın. Yazılım, metrik veya SAE için ölçü birimleri kullanabilir. Operatör ekranı her zaman milimetreyi gösterecektir. En iyi seçim, yazılımın milimetreyi de kullanmasıdır. Boyut birimi,'nin yanındaki açılır kutu, milimetre olarak ayarlanmalıdır. Bu seçimi, milimetre olarak bırakın. Bir sonraki seçim, yükleme yolunu bul içindir. Bu seçenek, özel bir dizine özel kuruluma izin verir. Varsayılan yükleme yolu, C şeklindedir. Kurulum yolunu özel konumunuza göre değiştirmek için bu seçeneği işaretleyin. Varsayılan yükleme konumunun kullanılması önemli tavsiye edilir. Çeşitli eklenti yazılım sürümlerini kurarken, normal koşullar altında, kurulum programı hedef yazılımı otomatik olarak bulacaktır. Yükleyici, hedef yazılımı otomatik olarak bulamazsa, bu seçeneği işaretlemeniz ve hedef yazılımı manuel olarak bulmanız gerekir. Kurulum yapılandırmanız tamamlandı. Kuruluma devam etmek için Yükle düğmesine tıklayın. Kurulum yapılandırmanız tamamlandı. Kuruluma devam etmek için Yükle düğmesine tıklayın. Yazılım kurulumu tamamlandı. Tamam düğmesine tıklayın. Yazılım kurulumunu değiştirmemize veya tekrar kurmamıza gerek yok. Kurulum yazılımını kapatmak için çıkış düğmesine tıklayın.
首先，我们打开浏览器，找到深圳市瑞达科技有限公司官网，找到下载中心，找到对应配套软件 RDWorks V8， 点击下载。 下载压缩文件，下载完以后，我们打开安装包，打开里面的安装软件，进入到安装界面以后，我们可以根据需要选择语言，选择尺寸单位，根据设备实际情况。 选择机器原点，然后选择安装即可。如果是使用视觉卡，我们还需要勾选 Mark 点视觉定位，根据相机型号选择相机驱动，然后再进行安装。同时 ，V8 还支持外挂第三方软件，比如 CAD、Corel 等等。 极大方便对图形、图像有更高要求的用户。关于外挂软件的使用和安装，后续我们将单独出一期视频进行讲解。如果是首次安装软件的用户，则需要安装 USB 驱动，方便后续使用 USB 线连接控制主板。软件安装完毕以后， 我们关闭安装界面，在电脑桌面找到启动图标，启动软件。进入软件界面以后，我们进入右下角的设备连接配置界面。软件目前支持 USB 串口控制和网线连接控制。首先，我们使用 USB 线连接主板。 点击测试，测试连接成功以后，会显示主板的型号。点击确认。我们再试试使用网线连接主板，点击添加，并且选择网络。这里我们需要先查看网关，确定网关 IP 后，输入对应数值。先通过 CAD 命令打开黑色窗口，输入 IP config， 然后按回车键，确定电脑的 IP 地址。根据电脑网关 IP 地址设置面板的 IP 地址。规则如下：4段数字，前3段要保持一致，第4段范围在0到255内，但不能跟电脑网关 IP 数值一样。比如这台电脑的 IP 为 192.168.1.204， 面板的 IP 可改为 192.168.1.55。软件上修改 IP， 需要跟面板上的 IP 保持一致。填写好后，点击测试。在这里也显示出主板的型号。再次点击确认，关闭连接。主板连接成功以后，界面会自动刷新。接下来，我们可以进入到调试界面，查看激光头当前的坐标。在单轴移动界面进行轴运动操作， 查看能否正常控制。
Lazer makinesini bilgisayara bağlanması. Lazer makinesinin bir USB flash sürücü bağlamak için ayrılmış bir USB bağlantısına sahip olduğuna dikkat edin. Bilgisayarı, bir USB flash sürücü kullanmaya ayrılan USB bağlantı noktasına bağlayınız. İlk kurulumdan sonra Windows, sürücüyü birkaç saniye içinde tanıyabilmeli ve yükleyebilmelidir. Bilgisayarın lazer makinesini tanıdığını doğrulamak için Windows aygıt yöneticisini kullanabilirsiniz. Lazer makinesi bağlantısı bir USB seri port olarak görüntülenmelidir. Bilgisayarımın ekran görüntüsünün COM3'teki yeni USB seri bağlantı noktasını gösterdiğine dikkat edin. RDWorks yazılımı, doğru seri bağlantı noktasını otomatik olarak bulabilir.
The options that we have are PC USB cable direct to the PC and the controller, an Ethernet connection via your network router to the controller, as well as transferring files to a USB flash drive and then loading them into your controller. Connect a USB cable between the PC USB port and your computer. RDWorks should automatically detect the USB and the COM port number for your computer and your controller. If your computer does not automatically detect, it may require a manual entry. To find out what COM port your USB is using, you can open up the Windows Device Manager and go to where it says Ports. Expand that and you'll see USB serial port, and it will identify the COM port number that you're using on your computer. To enter this into RDWorks, hit Setting, Add, USB, and select the COM port number that your computer is using, and then press Test. If it's successful, you get this message and it will identify the controller number here. Press OK and then select that device and exit. Connect a parallel Ethernet cable between your network router and your controller. So you can see here we have a communication icon, which is a picture of two computer screens, and there is a link between those two. When the Ethernet connection is disabled or disconnected, you'll notice that it changes to a red X. When there's an active Ethernet connection on the controller, the link light number 12 will be illuminated. The activity light is number 11 and will flash when there's network activity to the controller. To access the network connection, we go into Menu and we go down to Controller Settings. Press Enter. Across once to the IP config, press Enter, and we can see we can enter the IP address in up here. So using the number pad, we enter the IP address in of the controller, use the arrows to change fields, and then go down to right and press Enter. That will write that configuration to the control board, and we can see that we have set up success. Now to connect to our controller via the Ethernet, we go back into RDWorks, and under Device and the Setting button, we go Add. And what we're going to do is add a web IP address here. Enter the IP address that you entered on your controller and press Test. Once you've done that, you'll see it says Port Test Success. Say OK, and it will identify the controller that you have connected. Say OK, and then select the IP address as your connected device and exit. That will change down here. You can also select between the USB and the new Ethernet connection you've created using the drop-down arrow. To transfer your file from your PC to the controller using a USB flash drive, after you've created your file, down at the bottom we have LazerWorks, Save to U File. Give the file a name and save it to a USB flash drive. Connect the USB drive into the USB disk port for your controller. Now we press the File button and go down to where it says UDisk Plus. Press Enter. Now all we need to do is read the files from the UDisk by pressing Enter. We can see the file that we just saved there, and now we go across to copy to memory and press Enter. The information has been copied to the controller. We press Escape. Now to run that file on your controller, what we can do is press File, select the file that we've just saved to the memory, press Enter, and that will load it ready to press start.
Kullanıcı ve program parametrelerinin okunması. Masaüstünüze gidin ve RDWorks yazılım simgesini bulun. RDWorks yazılımını çalıştırmak için simgeye tıklayın. RDWorks yazılımı varsayılan modda başlamalıdır. USB'niz lazer makinesine bağlıysa, bir ilerleme çubuğu bazı parametrelerin yüklendiğini gösterebilir. Çalışma alanının boyutunun henüz lazer makinenize uyması beklenmiyor. Lazer denetleyiciden kullanıcı ve satıcı parametrelerini okumadan önce, yazılım henüz lazer makineniz için yapılandırılmamıştır. RDWorks durum çubuğu, 1024-768 PC ekran çözünürlüğünün iyi olduğunu önerir. RDWorks'u doğru kullanmak için 1600-900 ekran çözünürlüğünün daha iyidir. Kullanıcı ve program parametrelerinin okunması. RDWorks yazılımının sağ üst kısmına bakın. Kullanıcı olarak işaretlenmiş sekmeye tıklayın. Kullanıcı parametreleri görünecektir. Kullanıcı parametre düğmelerinin bazılarının lazer çalışması alan düğmeleri tarafından kapatıldığını fark edebilirsiniz. Kullanıcı alanı lazer çalışması alanı tarafından kapsanıyorsa, lazer çalışması alanını yoldan çekebiliriz. Fare imlecinizi, lazer çalışması alanının üzerinde bulunan çubuğun yakınına getirin. Fare imleci simgesinin bir dizi yukarı, aşağı oklara dönüştüğünü fark etmelisiniz. Lazer çalışması alanını aşağı ve yoldan çekmek için çubuğa tıklayın ve sürükleyin. Oku düğmesini görebilmeniz gerekir. RDA denetleyicisinden, lazer makinesinin içinde tüm kullanıcı parametrelerini toplamak için oku düğmesine tıklayın. Kullanıcı parametrelerinin %100 ünün okunduğunu gösteren mavi bir ilerleme görünmelidir. Kullanıcı parametre değerlerinin ayarlarının hiçbirini değiştirmemiz şiddetle tavsiye edilir. Kaydet düğmesine tıklayarak kullanıcı ayarları parametre değerlerini kaydedebilirsiniz. Kaydedilen dosya, lazer makinenize bağlı olmayan bir RDWorks yazılım kurulumunu ayarlamak için kullanılabilir. O asla lazer makinesine bağlanmayacak düzinelerce öğrenci bilgisayarını kurarken kullanışlı bir numaradır, ancak öğrenciler projelerini sınıf veya kişisel bilgisayarlarda geliştirmek isterler. Satıcı ayarları parametrelerinin denetleyiciden okunması gerekir. Dosya satıcı ayarları altındaki menü öğesini tıklayın. Satıcı ayarları, korumalı bir yapılandırma alanı olarak kabul edilir. Satıcı ayarlarına girmek için bir şifre gereklidir. Satıcı ayarları için varsayılan parola, RD 8888'dir. Satıcı parametre parolasını değiştirmek mümkündür, ancak genellikle bu parolanın değiştirilmesi gerekli değildir. Yeni satıcı parametresi parolasını unutursanız, RDWorks yazılımını yeniden yüklemeniz gerekecektir. Satıcı araçları için bir pencere açılacaktır. Oku olarak etiketlenmiş düğmeye dikkat edin. RDA denetleyicisinden tüm satıcı parametrelerini toplamak için oku düğmesine tıklayın. Satıcı parametrelerinin %100 ünün okunduğunu gösteren mavi bir ilerleme görünmelidir. Satıcı parametre ayarlarından hiçbirini değiştirmemiz şiddetle tavsiye edilir. Satıcı ayarları parametre değerlerini kaydet düğmesine tıklayarak kaydedebilirsiniz. Satıcı araçları alanından çıkmak için çıkış düğmesini tıklayın. RDWorks yazılımı tamamen yüklenmiştir. Kesme optimizasyonunda ince ayar yapmayı unutmayın.
Vendor settings include the main parameters for the operation of laser equipment, which are basic and important to laser operators. Then, let's have a look at them. The password is RD888, but the laser manufacturers may set other passwords. You can consult them for more detailed information. Here are motor, laser, other, and soft PLC inventor parameters, and the most important one is motor parameter. Motor parameter is set taking the axis as unit. First, let's read the parameters. For the direction polarity, it is the direction in which the axis moves, which is one of the most important basic operating parameters of laser equipment. The negative and positive in direction polarity is relative to motor motion. The setting of the negative and positive polarity varies with the direction in which the motor moves. And we just need to adjust the direction polarity to ensure that the axis moves in the right direction. Then, how to tell whether the direction polarity is right? There are many ways to do this, but here we will focus on just one. First, turn off the power and move the laser head to the center of the machine table manually. Then turn it on. If the laser head moves towards the mechanical origin, then it means the direction polarity is right. If it moves towards the opposite direction, then choose the opposite polarity, because the limit parameter may not be set correctly at this point. During the test, there is no need to reset the laser head completely to stop the test. Once we see the laser head, we can stop it. And pay attention that the reset speed should not be too fast. Otherwise, there may be a clean. After that, click Write to save the data. Remember that motor and laser control parameters, inventor parameters, can take effect only when the laser head is reset after modification. Limiter polarity is used to set high and low level modes for the limit signal. The mechanical axis can work with the induction device. Different manufacturers will choose various induction devices. And here is the metal induction device. It is easy to tell whether the limiter polarity works. Open the I/O menu from the panel, then manually trigger the induction device. If the corresponding signal changes, it means the limiter polarity works. If the motion axis inputs a low-level signal to the mainboard after arriving at a limit position, then the limiter polarity should be set as negative. Otherwise, it should be set as positive. There is Enable Limit Trigger in vendor parameters. It can stop the motion of the motor when the limit protection is triggered to prevent collision. Step length is a distance the motor moves after receiving a pulse signal. Also, it is the distance of the laser head moves when the move key is pressed once for the equipment. It is one of the most important basic parameters during laser working, which matters a lot in the processing precision. If the step length is not precise, laser processing will not be precise either. It is easy to adjust the step length. First of all, we need a big square. Usually, the bigger the rectangle is, the smaller the arrow is. Here, we will process a 200mm square for better measurement. After that, measure the length of the graph with the ruler. then enter the corresponding value in step length. And the step length adjustment is finished. Breadth is the further distance all the mechanical axis of the equipment can move. Usually, set the parameter according to the maximum size of the whole machine. Home offset means the offset range of the laser head from the origin. Enable home is to stop the run reset operation of the non-existent laser axis. If the machine has a certain axis, then you should check this option of the axis. If not, you shouldn't check this option. Other parameters such as the control mode and laser speed depends on the performance of the equipment. If the motor performance is good, the laser speed can be increased appropriately. If it is poor or used for too many years, the speed should be lowered properly. If the water protect is enabled, the controller must be connected with the water protection line. Otherwise, the machine will not output laser. If the enable protect is enabled, the controller must be connected with the enable protect line. Otherwise, the machine will not work. If the wind signal is used to control the switch of the blower by layer, then check enable blower. Broken delay is used for resume processing after power off. And later, we will make the operation smoother by the adjustment of the parameter. For more details, we will introduce them in the following videos. The setting of laser, other, and software PLC parameters also depends on the actual condition of the equipment. If some parts are changed, just modify them as required. The vendor parameters mainly refers to the basic parameters of the equipment. In actual manufacturing, people may encounter equipment failure.
Well, welcome to another RDWorks Learning Lab. Today we're going to have a go at tackling, if you like, the worst possible nightmare that you could ever have with this machine. I have touched on it before, and it's basically the disaster that will befall you if you mess up some of your settings. Now, you might be tempted, if you mess up your settings, to go back to the factory default settings, which technically the supplier of your machine, when they set it up, should have recorded for you in a section here. If we go to the ZU buttons, down here we get several different options. Now, one of them is set factory parameters. Now, we don't want to set the factory parameters because their factory parameters should already have been set by the manufacturer. What we do need underneath that is something called the default factory parameters. So you immediately think to yourself, wow, I'm out of trouble. If I press the default parameters, my machine will go back to being a normal machine. I happen to know that my machine was not set up, and if I press that, the first thing that will happen, if I select it, it will say, we need a password. The default factory parameter settings on this machine panel are HF and 4/8. So let's put that in and see what happens. It's a rather convoluted way of putting in the code because we've got this selection underneath here which we have to choose. So we've got to find the H, enter, and then we've got to find the F, enter, and then we've got to find the 8s, and it's 1, 2, 3, and I'm warning you, when you press the 4th 8 there is no enter to proceed. The 4th 8 will actually set the factory default parameters. Here we go. And it says recover success. Enter. Right, now that we're looking into the machine, I will press the enter button to complete this recovery operation. nothing happens. That's fine. So let's do a reset. Oh dear. Oh. So something of a bit of disaster has happened there. Wowee, that's not working like it should do. So first of all, let's press the arrow keys and see what happens. Whoa-wee. And again. Whoops, I'm going to smash that into the end stops if I'm not careful. So you can hear the machine is trying to accelerate far too quickly, and we're losing steps on the stepper motor. You can hear the motor going. So we've really well and truly screwed up. Thank you, Mr. Vendor. You didn't help me at all. At this point, I'm absolutely sure your heart will be in your boots. Where do I go from here? I've just screwed the machine up. Well, there are two things. First of all, on the previous disaster recovery video that I demonstrated this on first, I did tell you that you should make sure that while your machine is in good operating condition, you need to save the vendor and the user files. But in case you ignored that, what we're going to do today is to see if we can find out how we can recover from this disastrous situation without the aid of the files. Now, if we go hunting around, we will find the controller manual, and in there we have an explanation of the manufacturer's parameters. As usual, it's written in Chinglish, which makes it extremely difficult to understand. And the last thing that they do is tell you how to recover a machine or how to set up a machine. It's just an attempted explanation at the parameters themselves. So the first thing we need to do is to plug in a computer of some sort. Now I've got a laptop here, but it could equally well be a desktop computer. There are two connections on the side of your machine here. The top one or the bottom one, it depends how your machine is configured, will be the computer, and the other one will be for a memory stick. Right, so now we must go into RDWorks, and in RDWorks we need to go up here to File, and then we've got Vendor Settings. Now again, when you get to vendor settings, you will see that we require a password, and the password for the vendor settings is RD and 4/8. Now on this particular occasion, it doesn't immediately jump into something. You get the opportunity to think and say OK. Now there's nothing dangerous about doing this. What it will just bring up now is a list of the vendor settings, and down the side here we've got three options. We've got motor, we've got Lazer, and we've got other. Now the problem that we've got at the moment is with the motor, so it's probably on this page X and Y that we need to start working to start with. But before we do that, one of the things that's on this page is this thing here, which is the step length. So I've written a program which is 40mm square, and I've now put that into the machine, and I'm going to move the head. We'll just set that over towards 0 because my program is written with the 0 at that corner, and I'm now going to set the origin there, and what we'll do, we'll run this program and see what happens. Now bear in mind it's a 40mm square. Does that look like a 40mm square to you? Well, the answer's no. So one of the biggest problems that we're now going to face is we've got to set acceleration and speed, both of which are based on the true measurements of movement. Now, as we can see there, we haven't got true measurements at the moment. That 40mm is more something like 400mm. And so consequently we can't even begin to set the speeds and the accelerations up until we get the dimensions right. So that's almost the first thing that we've got to do. But how can we do that? We really need to paint a square on here so that we can measure it. But we really need the laser on to do that, and we don't know how the laser has been affected. So let's go and have a look at the laser page on the settings. So we really don't know how much the settings have been disrupted. So we'll go to the laser page, and what we've got in here at the moment are not necessarily the settings that are in this machine. And so consequently what we've got to do, we've got to read what the settings are. So we're going to the laser and we will read the settings. It says no connection. Well, that makes sense because I haven't connected. Now I'll plug my USB in and we are connected into the machine. So now I'll press the read button, and here we are reading the parameters that are set in this machine. The first thing it says at the top here, we've got multi-tube. No, we haven't. We've only got one tube, so we'll click that to one tube. We've got a glass tube, that is correct. So we don't want any laser attenuation. What we do need is we need to make sure that we've just got one head ticked, which we have. We certainly don't want head 2 ticked. Well, they're not ticked. Although they're all ticked across there, the 2 heads, the only ones that I've got available to play with are these here. So we've got minimum power 1%, maximum power 99%, which is fine. Laser frequency, well, that would normally be 20 kilohertz, and that is what it's set at, 20, so there's no problem there. So by default, signal level, and we do have water protect on this machine, so we need to tick the water protect button. Let's try and write that back now. So hopefully we've written that back into the machine. So let's read it again to make sure that it hasn't changed. One tube, glass, no attenuation, 1, 99, 20, and water protect. So good. So we've set the laser system up now, and hopefully we can turn the laser back on. Okay, now we've got 2 things here. We've got first of all a piece of A3, fairly thick paper. It's probably about 100 gram paper. And I've got a setting piece there which is the correct focus for the lens, which is about 5 millimeters. Just about right. So that will give me a nice fine line on the paper there now. We have seen that 40 millimeters is more like 400 millimeters, and the speed I set was 10 millimeters a second. So let's just run that again and see roughly what the speed is. 10 millimeters a second. We'll just do a frame. Oh dear. So the frame is really screwed up. So that's a speed that we're going to have to find out where we set that from. So if I run the program again dry, we know that the program was actually running reasonably well. Well, I think it's probably running at something like about 40 millimeters a second. Right, max power and min power are set to 12%, and the speed here is 10%, and the speed on here is 10 millimeters a second, but as you can see it's in reality about 40 millimeters a second. So we press enter and we will see what we get. Oh, I need to turn the laser on. So I'll just do a pulse test at that point just to make sure it's burning, which it is. Good. Now I suspect it's cutting right through, but that isn't a problem. And we have got 240 in X, 240 in X and 240 in Y. Okay, so now we'll go back to the motor and we get to X. Now beside the step setting we've got a little button with 3 dots on it. If we click on those 3 dots we get this option here, which is graph length. Well, graph length was in fact 40 and measured length was 240. Okay. Now we'll go and do that for Y as well, because that was 40, measured 240. Now I'm going to write that back, that information, and we're now going to just check whether or not it has made any difference to our program. Right, well I'm optimistic because I'm zooming in a little bit here, and we'll see whether or not we've made any difference to the program. Because it's running so much slower, it's cutting a bit heavy. Now it's possibly charred around the edge and made this a little bit smaller than it should be. But let's just have a quick check and see what the end result is. 40 millimeters. There we go. So we might need to measure that with a vernier later on to tidy that up a little bit, but give or take 1/4 millimeter, that's about right. So that's success number 1. Because the stepper motors are not moving as fast or as far, it's possible now that some of these other things will start to become more realistic. Let's just try what the arrow buttons are going to do now. Oh look, all of a sudden the arrow buttons have become more realistic as well. It's not running out of control. So let's move the head to the middle of the machine, roughly, press origin, and we will do a reset and see what happens. Now, you know what happened when we pressed reset before? The machine went into stupid mode. Reset. So perhaps it's not quite as bad as we thought, because by fixing the scaling we may well have solved several problems, including acceleration. Bear in mind I've got a 40 millimeter square. If it accelerates very quickly in and out of the corners, 40 millimeters square is 160 millimeters in total. Now I've got the speed set on this machine to 10 millimeters a second. So it should take somewhere in the region of between 16, maybe 17 seconds to complete the square. Now I've just set my origin point to there, and we know that it's not going to run out of control and smash into my phone. The problem now is we just must make sure that we turn the laser off. So we turn the laser off because we want this as a dry run. And so we'll just press this and the start button together, if I can. We seem to have good speed control, so we don't need to worry about the speed. Now I'm not so sure that we can actually do anything about the motor speed, because once you fix the distance, I suspect the number of steps issued at a certain number of steps per second is what controls the speed, and we don't seem to have any speed adjustment on here. Sorry, the y-axis is 400 millimeters a second, and the x-axis will be set a little bit faster because it's much lighter. It's only the head to move, not the head and the gantry. So that's set to 500 millimeters a second. Right, well I think before we start messing around with the motors themselves, if we are going to do anything further here, we need to just check what this other is, because there possibly might be some configuration that has to be done in this section here. Now the machine type says it's normal, which is correct. The transmission is belt and stepper motor, which is correct. What other options have we got? Screw drive, no. So it's definitely belt and stepper motor. And the feed mode, which I don't think affects us, it's a single direction. And then this broken delay underneath here, 750, that's typical of what was set on my machine before. The Z function is not operative, and the enable parameters, enable the blower, well, we haven't got control of that. It's not switched in, so we don't need it. But if you have got a blower, in other words the extraction system, what that means is that when you run your machine, the blower will switch on and extract fumes, and when you switch off at the end of a cycle, the blower will stop. By head auto layout, the distance between two heads, and because it's greyed out, I don't think it's going to have any effect on us at all. So there's nothing on there that looks as though it's changed away from how it's normally set. So we don't need to write anything back because we haven't changed anything. So we'll go back to the motors now, because that's where we need to make sure we've got everything working correctly. And I will just compare these figures that I've got here with what my normal figures were. Now the direction of the polarity, negative, and the one underneath is negative, that's correct. And then we've got control mode, which is going to be pulse plus direction. Step length 22.5. That's slightly different than what my original settings were, but we haven't set that properly at the moment. We've set it approximately. We need to be a little bit more accurate on that later. Now this breadth here is the width of your table, so I need to change that to 500. Home offset is 0, 0, and then we've got these things over here. Enable limit trigger, doesn't require. Rising edge was ticked on my previous settings, and enable home. On my original settings we had a jump off speed of 40, so I'm going to reset that to 40, and a maximum speed of 500 millimeters a second, which we agreed for X is about the right sort of speed. Maximum acceleration previously was set to 15,000, and the emergency stop acceleration is 30,000. And then we've got these at the bottom, jump off speed 15 and acceleration 4,500, invert direction, yep. So those settings there are now correct. Okay, let's take a look at the Y settings now, and these are correct at positive and negative, and the control mode is pulse plus direction. We've already discovered that this is maybe slightly wrong, but it's near enough. Enable limit trigger we don't touch, and the pulse width modulation occurs on a rising edge, which actually it isn't for Y. That's surprisingly correct, and we do need an enable home. And then the breadth is correct at 300, which is the dimension in Y for my table, 300 millimeters. And then we've got 15 for a jump off speed, which in fact should be at 20. Maximum speed of 400 in Y, because we're carrying the gantry as well, which is why we don't accelerate it quite as fast. We've got these numbers at the top here, which are 20,000. No, maximum acceleration is 2,000. That was the setting that I had before. Maybe it will run faster. And this emergency stop acceleration sits there at 10,000. Jump off speed 15 and 2, 0. Invert direction is left blank. Okay, so X and Y is all I've got on this machine. I haven't got a Z or a U. Now Z is obviously the auto sensing, the auto focus. If you've got autofocus, then you've got a Z axis which you'd need to set up as well, And if you have a rotary axis, one of these chucks, then you would need to set that up as well. But I have neither of those, so I don't have to worry about it. So what I'm going to do is first of all write those back, and one that we particularly changed was this jump off speed here, 20. So what I'm going to do is write it back. We're then going to have a quick read of it again. It should now read it, and it should read the same as we've just written, which it certainly does look as though it's done. So, with a bit of luck, we have nearly, in fact I'd say we probably have, with the exception of doing a detailed check on the dimension, we have reset the machine. Okay, well hopefully we think we've got the machine back under control now. So what I'm going to do is go to the speed parameters now. So let's just select that, and I'm going to change the speed away from 10 millimeters a second to probably something like about 100 millimeters a second. Now the reason I'm going to do that is because I just want to scorch a square on there. In fact, I'm going to make it 110 millimeters a second at 12%. And I'm going to turn the laser back on. It should fly around there and give me a reasonably accurate square. Okay, now as you can see this time we haven't got a lot of excess burning. We've got quite a neat square. Sorry, this time we're going to measure it with a caliper. So let's just very carefully check what that dimension is. If we take a look at that, 40 by 40, I mean that's 0.08, 3 hairs.
RDWorks ile basit bir daireyi kesmek. Aşağıdaki adımları yapılır. 1. RDWorks Windows uygulamasını açın. 2. Elips aracını seçmek için elips görüntüsüne sol tıklayın. Çalışma alanında bir daire çizmek için, çalışma alanına tıklayın ve basılı tutun, fareyi dairenin karşı köşesine sürükleyin ve ardından farenin sol düğmesini bırakın. 3. Daireye tekrar tıklayın. O daireyi kırmızıya çevirecek ve dairenin seçildiğini göstermek için gerilebilir düğümlerin vurgulanmasını sağlayacaktır. 4. Menü çubuğu araçları kullanılarak dairenin boyutu değiştirilebilir. RDWorks yazılımının sol üst kısmındaki boyut menüsünü bulun. Aracın hemen solundaki sayılar sağmal oklarla değiştirilerek dairenin genişliği değiştirilebilir. Aletin hemen solundaki sayılar yukarı aşağı oklarla değiştirilerek dairenin yüksekliği değiştirilebilir. Beş. Menü çubuğu araçları kullanılarak dairenin konumu değiştirilebilir. RDWorks yazılımının sol üst kısmındaki koordinat menüsünü bulun. X ve Y değerleri, çizim alanındaki dairenin konumunu gösterir. Daireyi yukarı veya aşağı taşımak için X değerini değiştirin. Bu lazer çalışma masasının önü ve arkası ile ilgilidir. Daireyi sola veya sağa hareket ettirmek için Y değerini değiştirin. X ve Y koordinatlarının çalışma alanının kenarındaki cetvele karşılık geldiğine dikkat edin. Altı. Elipsin boyutlarını değiştirmek için X boyutunda boyut ve Y boyutunda boyut alanlarına yeni değerler girin. Bu örnekte boyutlar 10 mm olarak ayarlanmıştır. Orijinal elipsin bir daireye dönüştüğüne ve şimdi tam olarak yazılan boyuta sahip olduğuna dikkat edin. Yedi. Her proje, projenin bölümlerini ayırmak için birçok katmana sahip olabilir. Her katmanın benzersiz özelliği rengidir. Bu tasarımda sadece bir nesne vardır ve bu nedenle sadece bir renk katmanı vardır. Bir sonraki adım, daireyi kesmek için hız ve güç ayarlarının değerini değiştirmektir. Şu anda Kes in gösterildiği mod sütunundaki katmana çift tıklayın. "8 katmana tıkladıktan sonra, katman parametresi penceresi açılacaktır. Kullanmakta olduğunuz malzemelerin uygun ayarlarını bulmanıza yardımcı olması için lütfen, kesme ve gravür malzemeleri için ortak ayarlar, veri sayfamıza bakın. Bu örnekte hız 10 olarak ayarlanmıştır ve minimum güç ve max güç 70 olarak ayarlanmıştır. İşiniz bittiğinde Tamam''ı tıklayın. Torque Power 1, 75 olarak ayarlanmıştır. Bu lazer kesmeye başladığında kullanılan ilk delme gücüdür. "9 proje tamamen tasarlanmıştır ve kaydedilmesi gerekmektedir. Projeyi bilgisayara kaydetmek için, Dosya Farklı Kaydet menüsüne gidin, ardından iletişim kutusuna dosyanın yeni adını girin. Bu dosya cirkletest.rld adıyla kaydedilmiştir. RLD dosya uzantısı, RDWorks programı içindir ve başka herhangi bir yazılım dosyası formatını göstermez. On çember çizilir. Lazer ayarları değiştirilir. Tasarım projesi bir dosyaya kaydedilmiştir. Bir sonraki adım, tasarımı lazer makinesine indir tıklamaktır. Bilgisayarın lazer makinesine USB kablosuyla bağlı olduğundan ve lazer makinesinin açık olduğundan emin olun. "11 indir" komutu, lazer makinesine yeni bir bağlantı başlatacaktır. Belgeyi adlandır penceresi görünecektir. Kullanılacak lazer makinesi için bir ad girin. RDWorks yazılımı, yalnızca belge adı için kullanılacak harfleri ve sayıları kabul eder ve maksimum 8 karakterle sınırlıdır. "12 bilgisayar, projeyi aktarmak için lazer denetleyici ile iletişim kurmalıdır." Bittiğinde, projenizin başarıyla aktarıldığını gösteren küçük bir pencere görüntülenecektir. Proje lazer operatör panelinde açılabilir ve kesime hazır olmalıdır.
让我们先不用小圆线束加工一个6毫米直径的小圆形。我们可以看到，直接加工后的效果并不理想。下面让我们用小圆线束功能优化一下试试。我们点开设置、系统设置、优化参数，找到小圆线束，打上勾。系统有一套默认的小圆加工速度，我们也可以根据自己的需求来修改参数。下面让我们看看加工效果。这下我们可以清楚看到小圆线束功能的作用了。再来看看选项卡，这些参数分别是 1.1 到 8.1 毫米的小圆加工速度，我们可以看看不同速度到底有什么区别。这里分别是3个长宽50毫米、30毫米、10毫米的方形，和3个直径分别是 8.1 毫米、4.1 毫米、2.1 毫米的圆。下面让我们来仿真加工一下，看看速度有什么不同。注意这里， 我们可以看到激光在加工原型时速度明显变慢了。我们实际加工演示一下。V8 是一套非常智能的控制系统，实际加工中可能会面对更为复杂的情况，但是无需担心。
RDWorks Markalama. Aşağıdaki adımları yapılır. 1. RDWorks Windows uygulamasını açın veya yeni bir proje başlatmak için dosya menüsünü kullanın. Metin aracının görüntüsü üzerinde fareyi sol tıklayın. Metni çalışma alanında çizmek için, metnin başlamasını istediğiniz yere tıklayın. RDWorks otomatik olarak metin düzenleme penceresini gösterecektir. Uygun metin yüksekliğini seçmek için metin penceresini kullanın. Genişlik istenildiği gibi ayarlanabilir ancak varsayılan değer çoğu amaç için yeterince iyi olmalıdır. Char space değeri, karakterler arasında daha fazla, daha az boşluk verecektir. Satır boşluğu, satırlar arasında daha fazla boşluk olacaktır. RDWorks, Windows işletim sisteminde yüklü olan herhangi bir TrueType yazı tipini kullanabilir. Metin alanına istediğiniz karakter dizisini yazın. Özel yazı tipleri, yazı tipi karakter eşlemesine karşılık gelen görüntüler üretecektir. Tamam düğmesini seçin ve metin çizim alanına yerleştirilir. Metin taşınabilir, döndürülebilir veya uzatılabilir. Bir aynanın, camın veya şeffaf akriliğin arkasına gravür yapıyorsanız, metni aynalamak isteyebilirsiniz. Altı metnin seçimini kaldırmak için fareyi metinden uzaktaki beyaz alana tıklayın. Metnin siyah bir ana hat olduğuna dikkat edin. Hızı, gücü ve modu ayarlamak için katman rengine çift tıklayın. Katman parametresi penceresi görünecektir. Geçerli mod, kes olarak ayarlanmıştır, bunun açılır menü ile tara olarak değiştirilmesi gerekir. Uygun ayarları bulmak için lütfen, kesme ve gravür malzemeleri için ortak ayarlar veri sayfamıza bakın. Bu örnekte hız 325 olarak ayarlanmıştır ve minimum güç ve max güç 45 olarak ayarlanmıştır. İşiniz bittiğinde tamam'ı tıklayın. Proje değiştirildi ve kaydedilmesi gerekiyor. Projeyi bilgisayara kaydetmek için, dosya farklı kaydet menü öğesine gidin, ardından dosyanın adını girin. Bu dosya Engraverabit, RDL adıyla kaydedilmiştir. RDL dosya uzantısı RDWorks programı içindir ve başka herhangi bir yazılım dosyası formatını göstermez. Metin çizilir. Lazer ayarları değiştirilir. Tasarım projesi bir dosyaya kaydedilmiştir. Bir sonraki adım, tasarımı lazer makinesine indirmektir. Bilgisayarın lazer makinesine USB kablosuyla bağlı olduğundan ve lazer makinesinin açık olduğundan emin olun. İndir komut düğmesi, projeyi lazer makinesine aktarmak için lazer makinesiyle yeni bir bağlantı başlatacaktır. Lazer makinesine yüklenen projeyi adlandırmanızı isteyen, belgeyi adlandır penceresi görünecektir. Proje adı, maksimum 8 karakter olacak şekilde yalnızca harf ve rakamlarla sınırlandırılmıştır. "11 lazer makinesi kesime hazır olmalıdır. Lütfen odağı ve uygun kesim malzemesi alanını kontrol etmeyi unutmayın."
Let's have a little bit of a look at the machine itself and see how we can now run this test. I've now got a piece of clear acrylic here, and I'm going to probably run this program twice. So what I'm going to do is, with my knife, I'm going to put a score across there, and I'm going to remove the plastic film from one side, and we'll use that for the first test. Right, although we've got our file in memory, it's not exactly ready to run yet. So if we press File again, we shall find that it's probably sitting here, and it's now available to us here. If we press Enter again, it now appears on here. We've got our two layer parameters shown here. If we press Enter again, we bring the cursor across to these two layer parameters, where we can choose, for example, between either of these two layers to edit the layer. So we press Enter to edit a layer, and here the layer is available for us to enter. Now we've got minimum power 1, minimum power 2. We know that 2 is not available to us, so we're only going to mess around with minimum power 1 and maximum power 1. And to get to these, you don't use the down arrows, you use the ZU key. So we're going to move from, at the moment, if you take a look up here, we've got the layer color active, and if we change that, we can go to black or red. So now we can come down with the ZU key to the first option, and then as we press the we then get the opportunity to change these if we wish, and we can do that with the arrow keys, change the numbers, and then we can just select every one of these windows with the ZU key, and when we've finished we just press Enter, set up success, Enter, done, escape. So we now do File again, and here's our file that we're going to run. Now one thing I like to do before I start is to do what they call a track. So we'll come down to track, and I'll press Enter in a minute, but I'll show you what will happen on the machine. Now bear in mind I've got nothing on, no laser, nothing at all. All I've got is the machine power on at the moment. So we can press Enter. So that's a big waste of material. We can either move the material to suit where the laser is moving, and that may not always be possible, but let's stay with that simple option at this point in time. Track, Enter again. And it does stop at the top left hand corner. So we can in fact move that down to about there. And we're now ready to run our program, except the fact we haven't got the machine switched on. So let's go through that routine of first of all switching on the water pump. Lots of air going through the laser. We'll wait for the air bubbles to clear. And there we go, we can hear that they're virtually cleared now. We'll now turn the laser on. I shall now turn the extractor fan on. and on my machine here I've got control of the air pressure that flows through the head here, the air assist. So I'm going to turn the air assist on because it's controlled by a pressure gauge and it's fed from my compressor, which you may hear turn on in the background. Now I've got something like about maybe half a psi of pressure in there. So we're all ready to run now. We will just come down to the menu again and we'll move this up to run, and then I shall just press enter. Right, here we go, enter. I'm going to press pause for a second. Now the reason I've moved the camera is I want you to look just here. Now there's this like a white halo down there. Now that's the acrylic. When the laser beam hits the acrylic, it boils off like steam. And this is like a condensate that's sitting down the side here. It's a powdery condensate. I will now turn off the air assist. I'll now turn off the air assist. So I'll press the pause start button. Now you see we're producing a lot more fumes, but you'll notice that we're not producing Now we can see here two things. First of all, when I turned the air off, all of a sudden it changed its characteristic. Look, it's only a powdery residue on the surface, but it recondenses on the surface and makes a bit of a mess. So it's a trade-off. And the other thing that we found is that we haven't got enough power here to cut through these items. So we need to go and modify the power or decrease the speed, which is probably the sensible thing to do. Then we'll come into the menu here and we'll press enter, and the one that we want to change is the cut speed, which is the black one. So we press enter, and at the moment we've got that running at 15 millimeters a second. I think we'll drop that down, so we need to come down with ZU and we need to reduce that speed to maybe we'll take it down to 10. So we'll move this left hand arrow key and it's gone under the 1. We'll move it with the right hand arrow key and it's gone under the 5. Now we can reduce the 5 to 10. There we go. And now we can just press enter. We can now just press enter, I think, and we should have done all the modifications. We don't need to change anything else. Setup success. Okay, so we're now ready to file. Oops. Run. I shall just press the enter button in a second when I get you back onto the machine. And I think this time what we'll do, we'll turn this round and we'll have a go at cutting through the protective film. And I will turn the air on again, the air assist, because I don't want to damage my lens. I want air passing through the nozzle. So it still hasn't dropped out because we haven't got enough power there, or this protective film on the surface here is absorbing more of the energy than I expected. So let's take the film off of the front and the back and run it again. The one thing I didn't check was the focus, and it does look as though the focus is out, and that may well be the cause of the problem. There we go, that's the correct focus now. That's a good reason why you should set your focus correctly. And there's our end result. We've got a lovely crystal clear edge. The surface is covered in this debris, which will just wash off, to be honest. But there's our first test piece with a few mistakes that I've made. Hopefully you won't step into the same problems.
RDWorks ile Bitmap'ı içe aktarmak. Bir RDWorks Windows uygulamasını açın veya yeni bir proje başlatmak için dosya menüsünü kullanın. Dosya, içe aktar menü öğesini kullanarak grafik dosyasını içe aktarın. İstediğiniz grafik dosyasını bulun. Uyumlu dosya biçimleri şunlardır. Bu örnekte RDWorks BMP dosyasını kullanmayı seçtik. Orijinal dosya aslında mavidir, ancak bit işlem gri tonlamalı olarak içe aktarılacaktır. Dört grafik dosyası çok yumuşak renkliyse veya bazı temel ayarlamalar gerektiriyorsa, RDWorks'un bu tür ayarlamaları yapmak için dahili bir yöntemi vardır. Bitmap grafiğini vurgulamak için tıklayın ve ardından Bitmap Hande menüsünü seçin. Uygulama penceresi, Bitmap Hande olarak adlandırılır. Bitmap işleyici penceresinde görüntü düzenleme seçenekleri şunları içerir. Sıfırlamak için düğmeli bir parlaklık kaydırıcısı. Kaydırıcı artırıldıkça renkleri daha açık hale getirecektir. Sıfırlamak için düğmeli bir kontrast kaydırıcı. Açık renkleri daha açık ve koyu renkleri daha koyu yapmak için iyidir. Rengi tersine çevirmek için bir onay kutusu. Çözünürlüğü ayarlamak için bir seçenek. Ölçülen piksel inç. Taklit seçenekleri şunları içerir. Net grafik. Gri alanlarda beyaz ve siyahı değiştirerek gri tonlamadan siyah-beyaz bir görüntü üretecektir. Nokta grafikleri. Gri alanlarda beyaz ve siyah noktaları değiştirerek gri tonlamadan siyah-beyaz bir görüntü üretecektir. Siyah-beyaz, bir görüntünün ana hatlarını elde etmek için en iyi sonucu verir, ancak istenmeyen sonuçlara neden olabilir. Gri tonlama, bu görüntü zaten gri tonlamaya dönüştürülmemişse kullanışlıdır. Keskinleştirmek, bu görüntünün kenarlarını tanımlamaya yardımcı olur. Görüntülemek için uygula, ön izleme düğmesi görevi görür. Kaynağı uygula. geçerli ayarları görüntüye uygulayacak. Taslağı al. Bu özellik, görüntüyü ana hatlarıyla belirtmek için yavaş olabilir, bu nedenle görüntüyü değiştirdikten sonra kullanın. Farklı kaydet, değiştirilen görüntüyü bilgisayara kaydeder. Beşinci değişiklikler bittiğinde kaynağı uygula, ya basın ve menüden çıkmak için tamam A basın. Bu eğitimde, görüntü siyah beyaza dönüştürüldü ve görüntünün kesilmesine izin verecek şekilde dış hatları çizildi. Ana hat al, mod kes olarak ayarlanmış şekilde yeni bir renk katmanına yerleştirilen bir vektör grafiği üretir. Orijinal BMP renk katmanını gizlemek, yeni ana hat resmini ortaya çıkaracaktır. Altı katmanlar menüsünde uygun katmana çift tıklayarak kesme, tarama ayarlarını değiştirin. Uygun ayarları bulmak için lütfen, kesme ve gravür malzemeleri için ortak ayarlar, veri sayfamıza bakın. Bitmap, katman renginde BMP olarak etiketlenir ve yalnızca tara olarak ayarlanabilir, ancak ana hatlar yukarıda gösterildiği gibi farklı bir katmanda kalır. Bu dosya RDWorks adıyla kaydedilmiştir. RDWorks dosya uzantısı RDWorks programı içindir ve başka herhangi bir yazılım dosyası formatını göstermez. Yedinci proje yerleşimi tamamlandı. Lazer ayarları değiştirilir. Tasarım projesi bir dosyaya kaydedilmiştir. Bir sonraki adım, tasarımı lazer makinesine indir tıklamaktır. Bilgisayarın lazer makinesine USB kablosuyla bağlı olduğundan ve lazer makinesinin açık olduğundan emin olun. Sekizinci indir komutu, lazer makinesine yeni bir bağlantı başlatacaktır. Belgeyi adlandır penceresi görünecektir. Kullanılacak lazer makinesi için bir ad girin. RDWorks yazılımı, yalnızca belge adı için kullanılacak harfleri ve sayıları kabul eder ve maksimum 8 karakterle sınırlıdır.
Hello everyone, this time I will show you guys the functions of photo processing in laser processing. Before that, let's get a difference between bitmap and a vector out there. Bitmap, also called dot matrix image or raster image, is composed of single pixels. When the bitmap is zoomed in, countless squares can be seen. The photo of BMP, JPG, GIF, and PNG formats belongs to bitmap. Bitmap has rich colors and a vivid image. The sharpness is related to resolution. Usually, the higher the resolution is, the more pixels the image contains, and the sharper it will be. Vector is object-oriented image. The graphic element in vector files is called object, and every object is independent. It has properties such as color, size, shape, and so on. Vector graphic can only be generated by the software, such as CorelDRAW, Illustrator, CAD, and so on. It features no distortion when zoomed in, so it is suitable for the professional graphics or text design. Next, I will show you the bitmap handle function in RDWorks software. First of all, we should import a picture. Then click bitmap handle function. Here is bitmap handle interface. At the top of the function bar, we can see the values of image pixel and resolution, and they will be updated when the output resolution is modified. Brightness and contrast mean that adjust the brightness and contrast to achieve the effect in line with the processing needs. and they can be used with the options in the bar. Click Apply to view to see the result after modification. Click Full Screen to see the display effect of the whole image. Invert color is to invert the black and white of the image. For example, in this Panda picture, the color of the belly is light. If we want it to be darker, we can click Invert Color to convert it. For different processing, various data methods can be used for different processing effects. The net graphic is suitable for the occasion where the spot produced by laser on the surface of the processing material is large, or the laser response is slow. Net setting needs to adjust the resolution and the net frequency of the image. The higher the resolution is, the clearer the graphic will be. The higher the frequency is, the smaller the net will be. That graphic can achieve better gray processing effect. It is suitable for the occasion where the spot produced by laser on the surface of the processing material is small, or the laser response is quick. Sharpen can quickly focus the blurry edge and increase the sharpness or focal length of a part of the image to make the color in a particular area more vivid. Grayscale and black and white are to transform the color picture into a gray, black and white display effect. Import the bitmap to RDWorks software and grayscale is generated by default. Black and white is suitable for processing the image with clear color and outline. It is easier when used. For some bitmaps that are easy and need to extract the outline, the Get Outline function can be used. After that, click Apply to view to see the effect, or click Apply to source to generate the final image. Apply to view can cancel modification. After clicking Apply to view, the picture imported to RDWorks can't return to the original state. Click OK to save the image effect after modification, and then exit the bitmap handle interface. The image after modification can be saved as. So, we can see the bitmap handle function is not complicated. You can have a try by
Dokuzuncu bilgisayar, projeyi aktarmak için lazer denetleyici ile iletişim kurmalıdır. Bittiğinde, projenizin başarıyla aktarıldığını gösteren küçük bir pencere görüntülenecektir. Proje lazer operatör panelinde açılabilir ve kazımaya ve kesmeye hazır olmalıdır.
Now, today we're going to try and produce this horse picture with dot graphic as opposed to the net graphic that we used in the previous session. The result of this session could finish up horribly wrong, but bear in mind this is a learning experience, so hey, we take it as it comes. So I have fumbled with this software just a bit to give the impression that I know what I'm talking about when I speak to you guys. Quite a lot of where we're going today is new territory for me as well. So I think the first thing that I shall do is do a Control C for this picture which is on the screen, and we'll stick another one down beside it, Control V, because I want to work with two pictures. Right, before we dive into the graphics itself and start doing something with these pictures, I'm just going to go across here to the bitmap tooling that's at the top here, and we're going to take a look down here at the bottom, and you'll notice that I have set the interval to 0.3 of a millimeter. Now that's the scan interval, because bearing in mind this is a scan image, and as we work across these pictures we're scanning lines, and every time we scan a line we then move down by 0.3 every time we scan a line. We're now going to open up a bitmap handle on our first picture, and I've already shrunk this picture down as we did in previous session, and you'll see that the pixel resolution is 1024. So in this picture we have control of the output resolution, and at the moment the output resolution by default is set to the same as the picture resolution, which is 1024. Now remember we said the scan lines are 0.3 of a millimeter apart. Every line that goes across the page now is going to have 1024 dots per inch before it gets to the other side. When you stop and think about it, we've set the vertical scan down the page here to 0.3. The dots are not going to change size. They're going to produce probably dots about 0.2 or 0.3 diameter, maybe even bigger. Therefore, what is the point of having a load of dots sitting on top of each other across this page? We may as well reduce the resolution of the number of dots so that they sit next to each other as the lines do. So really we're looking at dots which are 0.3 diameter per inch. Now there's 25.4 millimeters in an inch, and if the dot is 0.3, that means we actually get 85, not 1024 dots per inch. If we reduce that to 0.2 of a millimeter dot, it goes up to 127. And if we reduce it to 0.1 pitch every dot, that's still only 254 dots per inch, a quarter of the resolution that we're currently being offered. I think that probably we might start our picture off with 85 dots, which is a sensible, what I consider to be a sensible theoretical resolution. Now we'll go into this dither command. This no longer has any function because it's nothing to do, it's all to do with net graphic, and we will choose dot graphic. It's as simple as that now. So we've just do apply to view, and we take a look at the view. Looks a bit strange, but if we apply that to the source, whoops, okay, get rid of this, and then we zoom the source in and out, there is a point where it, obviously there's an interaction between the dots and the resolution of this screen, and that's why it looks strange at times. I don't know what this strange artifact is here. We'll give it a try. You might ask the question, why have I put a second picture in there? Well, let's just put handles on that for a second, and we'll go back to our bitmap handle, and this time we're going to do something called invert. We're still going to put our resolution down at 1000, from 1024 we're going to set that to 85. Dither, dot graphic, and apply to view. Now it might look a bit strange, but I think that anything that's black will be scanned or cut. On this left hand picture here, anything that's black will be laser cut, and in this particular picture anything that's black will be laser, they'll be scanning across this area here. So we shall scan black, and then we'll go dot dot dot dot dot dot where the black dots are, not where the white dots are. So let's see whether or not we can get any more detail in the eye by just changing the contrast and the let's put the contrast and the brightness up by 10% and see what we get. Nope. Contrast down to 0. Just leave the brightness there at about, maybe let's track it down to about 10% and see what happens. I think that's probably the best of all worlds. So we'll do apply to view, and then we'll do apply to source. Okay, and there are our two pictures. So we've got a positive and a negative, and the reason I've done that is so that we can compare the difference between the two types of picture. Now you wouldn't think about normally producing a negative picture, but depending on the surface that we're going to etch it onto, it may work. So we'll just go and check what these outputs might look like with our preview, and surprisingly enough the one that's negative might come out quite well. Now the one thing we've forgotten this time is our little name tag. So we'll first of all use Harry again, okay, and we'll change the size this time to maybe 10. let's learn a lesson from some of the mistakes we made last time. Before we put Harry anywhere near these pictures, we need to make sure he's on a different layer. So we'll change him to a red layer. Then we can probably find, no, blue layer. Harry. Yeah, we had him on a blue layer last time, so he'll be scanned. He'll be the same values that we had last time. So there he is, Harry. Control copy, Control V. And before we put any of these together, let's put a rectangle around here. And we'll make that rectangle, put handles on the rectangle, and we'll make that a red layer, which is a cut layer, I believe. Handles on the rectangle again. Control copy, Control V, and it's already a red layer. And let's move that around this one. Let's not get too fussy this time, just put it on approximately. And then we'll put our Harrys in place. Harry and Harry. Well, there's experience for you. That was a lot quicker than the last time. And hopefully our tooling should be nearly set up for us. So let's have a look at the black. Yes, speed. Dots are very quick apparently, so yeah, we can do dots at 200. Scan, yes. Power, I don't know, we don't need huge amounts of power to put dots down. I think we might drop that to maybe 30 and 30. Okay, now go for our scan, our Harry scan, and we could leave that as it was last time because that worked okay. And now we do our cut. And in fact last time we cut it out of 8mm material, didn't we? So we actually had to reduce the speed right down to, I think I reduced it to 5, and it only just made it through. So I think I might use thinner material this time and just stay with 10. Okay. Right, and let's move on to the machine. Well, here we are. We're not going to bother with all the formalities of loading the program and setting up the machine. We've done that enough times now for you to know exactly what's going on. So I've even done my tracking. So really all I've got to point out is the fact that I'm using a piece of 1.7 or 1.8mm thick acrylic this time. That's not set to the right depth, quite an important thing. That's about right now. That's the clearance under the nozzle, which will give me the correct focal height. We'll turn the air pump on. The air assist, the pretty pathetic air assist, but I'm waiting for some air filters to come, and when the air filters do arrive, I shall start using my compressor again. Okay, let's go! Burning the burning my bed of nails underneath there. I must have far too much power. Let's have a look, see what we got. Yeah, we definitely did a bit of burning under there. We've got some soot on the back here. Okay, so here we've got our two pictures on a black background, now that I've cleaned them up, and all I did was clean them up with fairy liquid and a toothbrush, just to get into all the dots. And here's what they look like on a white background. As you can see, there's quite a lot of detail. You can almost see his eye there when you catch the light right. Now let's go and have a little bit of a look at how this is all achieved, because I thought it was done with dots. And what we'll have a look at, we'll look at this little area here where the ring on his head collar is, and this little bit here. Now if we look carefully, we can see just here the ring, and then we can see the scan lines, and the scan lines are just about touching each other, but there's a little teeny weeny gap in between. So bearing in mind I set the scan lines to 0.3, maybe they could come down to 0.2 and not be quite as obvious, because there'd be a bit more of an overlap. And when it comes to these dots that I thought were going to occur, particularly if we look down here, we can see behind my finger here that they're not all dots. When I put a black background on there, you can see there are some dots and then straight lines. So depending on the density of the picture that's required, take for example up here at the top of this nose band, look, we've got stripes that run across there. So I think we could get maybe a slightly better picture by reducing the lines to 0.2 and maybe reducing the pitch on the dots to 0.2. So maybe we should go and try that. Well, the one on the left is our original program, and the one on the right has got double the number of dots on it. And although there are certain parts of it which are slightly more defined, I think on balance maybe I could fiddle with the contrast a little bit, but I still think that probably the 0.3 dot spacing is probably better than the 0.2 dot spacing. So there's a comparison with what we had before. There's our 0.2 dot spacing, and quite strangely there don't seem to be as many lines in there. When we compare it with the 0.2 graphic, nothing has changed, absolutely nothing, except the density of the dots and the closeness of the lines. It seems to make a remarkable difference to the quality of the picture.
Güvenlik değerlendirmesi ve bakım. Güvenlik değerlendirmesi. Makinenin topraklama yapılmadan çalıştırılması yasaktır. Lazer gücünün topraklama kablosu toprağa bağlı olmalıdır. Kapı, pencere, su boruları ve benzeri tesislere bağlanamaz. Tel dış zemine çekilmelidir. Makineyi her çalıştırdıktan sonra dalgıç pompanın suyu tahliye edip edemediğini kontrol edin. Pompadan su çıkamadığında makinenin çalıştırılması yasaktır. Operatörler gereksiz kayıpları önlemek için çalışırken makineden ayrılamazlar. Sirkülasyonda 20 kilogram su olduğundan emin olmak için su kabı biraz daha büyük olmalıdır. Su sıcaklığı yaklaşık 25 derece olmalıdır. Sıcaklık çok yüksekse su değiştirilmelidir. Herhangi bir kirlenme olmaması için arıtılmış su kullanmak daha iyidir. Sirkülasyon suyu düzenli olarak değiştirilmelidir. Makinede lazer ve yüksek basınç olduğu için profesyonel olmayan çalışanlar izinsiz makineyi sökmemelidir. Atı yansıtıcı ayna ve odaklama merceği, alkol ve eter karışımıyla ıslatılmış tıbbi kullanım için özel kamera merceği kağıdıyla silinmelidir. Ayna ve lens temizliği haftada bir yapılmalıdır. Makinenin zarar görmemesi ve statik elektrikten kaynaklanan yaralanmaları önlemek için makinenin tüm parçalarının ve kullanıcı bilgisayarının topraklamasının güvenli olması gerekir. 7. Gravür yapılırken ayna ve lenslerde kirlenme olmaması için fan açık olmalıdır. Yangını önlemek için herhangi bir yanıcı ve patlayıcı eşyayı ekipmanın yakınına koymak yasaktır. 8. Lazerin doğrudan insan vücuduna veya yanıcı maddelere yansımasını önlemek için ekipmana alakasız herhangi bir toplam yansıma veya dağınık yansıma nesnesi yerleştirilemez. Dokuz. Tüpün donarak çatlamasını önlemek için kışın lazer tüpündeki su çekilmelidir. Makine çalışırken, operatörler çalışma koşullarını incelemelidir. Giriş ve kamyon elle çekilemez. Makine, kirliliğin, güçlü elektriğin, güçlü manyetizmanın ve benzeri müdahale ve zararlı etkisinin olmadığı yerlere konmalıdır. 12. Voltaj sabit olmadığında lütfen makineyi çalıştırmayın. Voltaj regülatörü kullanılması tavsiye edilir. 13. Eğitim almamış kişiler makineyi kullanmamalıdır. 14. Tuşlara ve düğmelere kuvvetlice vurmayın. Bu tuş ve düğmelerin zarar görmemesi için lütfen hafifçe bastırın. 15. Hasar veya yangın olması durumunda lütfen hemen gücü kapatın. 16. Gök gürültüsü veya şimşek çakarken makineyi çalıştırmayın. Kullanıcılar yukarıda belirtilen tüm düzenlemeleri dikkatli bir şekilde takip etmelidir. Aksi takdirde, makinede meydana gelebilecek arızalardan veya fiziksel yaralanmalardan üretici sorumlu olmayacaktır. Bakım. Bir soğutma suyu. Yaklaşık 25 kilogram soğutma suyuna ihtiyaç duyar, suyun sıcaklığı 35 dereceden yüksek değildir. Dolaşan su, safsızlık içermeyen saf su kullanmalıdır. Soğutma makinesini seçmeyi önerdi. Lazer tüpü. Lazer tüpünde kabarcık olmamalıdır, aksi takdirde tüp yok olacaktır. Lazer tüpü çalışırken akımın 20 miliamperin altında olması önerilir. Daha yüksek akım, daha kısa ömür. Lazer tüpü parçalandığında veya bittiğinde değiştirilmelidir. Odak merceğinin temizliği. Lens bir süre kullanıldıktan sonra temizlenmelidir.